Good evening, everybody. Welcome to Lambda School's Mini Bootcamp. We are now on lesson 8 of our 12-part series, so we're coming to the end of our second week. I hope you guys have been enjoying what we've been learning so far. On our first week, we covered some introductory topics. We learned all about Git and workflow, learned a little bit about HTML, CSS, and then I introduced you guys to JavaScript. This week has been a complete deep dive into JavaScript. We've seen a lot of cool stuff in just a short amount of time, and tonight is no exception. So tonight we are going to be diving into class instantiation and building customized classes in JavaScript. So you'll learn in a minute what that actually means, but essentially it's our way of building customized data types in JavaScript. And it's a really key topic when it comes to object-oriented programming. So it really is this neat way to look into what's going on behind the screens in JavaScript and some insight into other languages like Java or C, C#, C++. So before I jump into our topic, for anyone who's new, my name is Deandra Ryan Moss, and I am an instructor here at Lambda School. And let me tell you a little bit about Lambda School itself. So the main curriculum of Lambda School is a 6-month computer science and web development immersive. So what we do is we take you from the point where you just know a few introductory topics and get you to a position where you're ready to be hired. You're ready to enter into the job force. So it's a full-time program. It's entirely online. It's a combination of lectures, group work, projects, homework, Q&As. It's a really dynamic course, and it teaches you a lot of good topics. We're going to In the main curriculum, we go deeply into everything you've seen in this mini boot camp. With front-end development, we also completely dive into back-end development, and then we work in some computer science topics as well. And one of the best things about Lambda School is that we use a de-risked education model, which means that you do not actually have to pay anything upfront. We have an option where you pay 0 upfront and you pay us once you get that full-time job. So once you have gotten a full-time job in the industry working over or making over 50K, then you can pay us back over the course of the first year or the first 2 years. So under this model, we are extremely motivated to bring in people who we know are going to return on our investment, people that we think are capable of learning this material and capable of getting an awesome job. So you might be thinking to yourself, uh-oh, what kind of crazy interview process does this school have? And it's actually not too intimidating. So we do not even do a technical interview at Lambda School. We're more interested in culture fit. We're more interested in finding people who are really motivated to learn. From our perspective, it's not about what you know, because it's our job to teach you. It's about your capacity for knowledge, your willingness to work hard, and your dedication to this material. So, and one of the big things we look for in our interviews is actually to see that you've completed this Mini Bootcamp. So just by being here with me for these 3 weeks, we're already going to look at you in a pretty high regard. So if you are interested in the main curriculum, then please reach out to our admissions team. We would love to have you in our 6-month full-time course, or if you're not able to do a full-time, we do a year-long program that's only in the evenings. So we have a year-long part-time if that's what works for you. So definitely reach out if you're interested in that. As far as this mini boot camp, this is a 3-week kind of introduction course, totally free, available to the public. And if you are here for the first time tonight, it might be a little rough to jump in since we're almost finishing week 2, but everything is available on YouTube if you want to go back and look at old lessons. And we'll be running a new one in May, so you're welcome to start then as well. So whichever approach you want to take. Well, with all of that being said, I think we are ready to talk about some class instantiation for tonight. So I'm going to go ahead and do a little review of what we saw with objects from last night, and then we can jump into learning how to build classes. So I will share my screen and we can get going with the programming. Okay, so up here on my screen, I have an object. So this thing is called Ninja Assassin, and it contains several properties as well as one method. So as a little review of objects and how they work, you always instantiate objects using the curly brackets. And then inside of the object, you can create a list of properties and methods. So the difference between properties and methods are that properties contain some sort of single value like a string or a number or a Boolean. We have an example of all three of those here. So the three properties on this Ninja Assassin object are codename, weapon, stealthy, and head count. And then we have one method. The only difference between a method and a property is that methods are functions. And so you could think about all five of these as being key value pairs with 4 properties and 1 method. And they're all separated by commas. Our key name is going to come first, followed by a colon, and then after that is our property. And of course, if we want to access anything on this Ninja Assassin, we can use dot notation to look it up. So we could do ninjaassassin.codename, and it will appear. We could do the same thing with head count if we wanted. And then we could also run the kill method. So with methods, because they are functions, we need to follow them by parentheses. So if we go ahead and run that and then see what's inside of our Ninja Assassin, we see that, as expected, the kill function increments our head count up to 1. So that's what's going on inside of this function. We just have the head count on our object being incremented using the ++ operator, which I know we saw a couple nights ago with Luke. So that is a little bit of a summary of what an object is. So before we get into what classes are and when we would want to write a class, I want to explore this idea of creating assassin objects a little bit further. So we have this Ninja Assassin here, but let's say we wanted to create a different type of assassin. So I'm going to create a new assassin object called character assassin. And character assassin is going to be pretty similar to Ninja Assassin. There's the code name. And then we, of course, want a weapon. We want a stealthy value. Head count, which I'm going to always start head count at 0 so that our kill function has a fresh slate. And then we want this kill function, which is going to look exactly the same. We just increment the head count. So now we have 2 assassins, our Ninja Assassin and our character assassin. Let's say we wanted a third one. I will call this one Ghost Assassin. And it's going to be pretty similar. So I'm actually just going to copy and paste everything out of here and change some of the values. So we'll call this one the Wraith. Its weapon is Spirit Magic. Oh, our character assassin is actually not very stealthy. Its stealth value is true. Head count starts at 0 and the kill function stays the same. So now I have created 3 different distinct assassin objects. And if you guys have been paying attention throughout the last few lessons, you'll hopefully have noticed that I have just broken one of my fundamental rules of programming, which is that I have repeated myself like crazy. I noticed that the kill function and the head count are exactly the same on all 3 of these. And even though the values are different on these other properties, the key names are all the same. So there's this pattern going on here. There's this pattern between these 3 objects. And whenever we see a pattern, we don't want to repeat ourselves. We don't want to keep writing the same thing again and again and again. So this is a good sign that we need to do something a little different. If we want to keep creating these assassins that have very similar values in them, we need some way to template them. And that's exactly what classes do. If we want to create different types of similar objects that have slightly different values in them, we would create something called a class, which is basically just a template. So in essence, what we're doing is we're creating a new JavaScript type, an assassin type. So let's go ahead here and do a class declaration. Is that how you spell declaration? Hopefully. I apologize for my spelling if that is not correct. So, okay. So instead of creating an individual assassin, we're going to create something called assassin. And this is a new JavaScript type. So before I continue, I want to mention that notice that I have capitalized this variable name. Every other variable name that we're used to creating is always lowercase or camel case. But when we create a new class, by convention, we always capitalize it. And that's an easy way to let our fellow programmers know that this thing is supposed to be a class. Notice that what we do on the other side of the equal sign looks exactly like we're creating a function. So syntax-wise, creating a class is really similar to creating a function, but this capitalized variable name is going to be our first clue that this thing is a class, not a function. So similar to a function, we'll have parameters. And the parameters should be everything that needs to be customized. So up here we saw that between our 3 different assassins, there were 3 of these properties that became kind of customized: the code name, the weapon, and the stealth value. So I will go ahead and put those in as parameters. We'll do code name, weapon, and stealthy. So whenever we create a new assassin, we'll be able to customize what these 3 values are. So in order to save them into our actual assassin object, we use the keyword this. So I would say this.codename equals codename. This.weapon equals weapon, and then this.stealthy equals stealthy. So now I have taken these parameters, the input from whoever's creating a new assassin, and I've saved them onto the object that will be returned. So we're using the keyword this, which I briefly introduced you to last night. We will talk a lot more about this later in tonight's lesson. But I want to talk about what each of these lines are doing in a bit of detail because this can get a little confusing. So when we say this.codename, so what is on the left side of the equal sign, what we're saying is on the new assassin object that we create, we want a property called codename. So that is all this line of code is saying, is on the new assassin that we're about to create, give it a property called codename. Over here, we're saying set that property equal to the argument, whatever is inputted from our user. So notice that I could actually change this to X, Y, and Z, and then change it down here, and it would work exactly the same. We're naming our property codename, but we're setting it equal to the very first parameter. And same down here. We wouldn't want to do this because X, Y, and Z are super non-specific variable names, so we don't like that. But I just wanted to clarify that the word codename on the right side of the equal sign refers to the input from the user, whereas codename on the left side of the equal sign means put a property called codename on our new assassin. All right, so we have codename, weapon, and stealthy set up, but we still need our head count and our kill method. So I will go ahead and do this.headCount equals 0 because in every case we want to auto instantiate it to 0. We want it to start at 0 every time. So we can just hard code that in. And then finally, I will do this.kill, and I can just go ahead and write in that function. Do this.headCount plus plus. Okay, so we were able to hard code in the head count and the kill function because they are going to be the same in every case. So we have just created the class function for assassin. So this is our templating logic. This tells us how to create assassins. So let's see how we use it. And I'm going to go ahead and comment all of these guys out for now because this is a good example of what not to do. So down here, we can now go ahead and create new assassins. So if I want to create my ninja assassin, I use the assassin class function with the keyword new. So let me go ahead and put in my arguments, and then I'll talk a little bit about that keyword new. So we want this guy to be called Hollow Eyes. His weapon is a katana. And then we want the stealth value to be true. over a little bit. Okay. So now we have created our new ninja assassin. And if I run this, we can see that we were able to create this object, this exact same object that we explicitly declared up here. We're able to create it instead using the class of assassin, which is a much sleeker, neater way to create this object. And I'll talk a little bit more about why that is in just a moment. But let's go over the syntax before we get on to anything else. So as I said, when we declare our assassin class, the syntax is very similar to creating a new function in that we use the function keyword and we have parameters. When calling this new class, the syntax is similar as well in that we call it with parentheses and we put in our arguments. However, there is one difference, and that is that we use the keyword new. So the keyword new is our way of telling JavaScript we're not just calling a function, we're actually creating a class. And this is really critical because over here, a couple things will happen behind the scenes when this function is run with the keyword new. The first thing that happens behind the scenes is that we will create an object called this. The next thing that happens is that we will return that object at the end. So if we were just running this as a regular function, there's no return statement that we've explicitly written in. So nothing would be returned. But when we use the keyword new, these things happen behind the scenes. So we don't have to write them in. They're out of sight, out of mind. But I just went ahead and commented them in so that you guys could get an idea of what's going on. So if I forgot the keyword new, Ninja Assassin would be undefined because the assassin function, if we treat it just as a function, has no return value. But if I use the keyword new, then the computer knows, okay, we want to create this object and return it. So we're able to get this returned copy of everything that we said on this inside of our function. So the keyword new, pretty important. Now let me go ahead and create the rest of our assassin friends. So we had our character assassin. And once again, we'll use the new keyword. We'll put in all of our arguments. And then I want to finally create our ghost assassin. Okay, so notice that the syntax for creating all three of these was exactly the same. We just changed what arguments we put in to customize each of these assassins. So now if I console log all of these, you can see that they all appear on our console. So we've successfully created all three of these. So let's take a look at how I did this at the very beginning of the lesson. So this up here was 30 lines of code. Down here, especially if we get rid of some of these white spaces, this is about a little under 15 lines of code. Or it's about 15 lines of code. And we have done, oh, and that's including the console log. So if we just look at what it took to create these three assassins, not very much code, about 15 lines. So we've used half the amount of code to do the same thing. And not only that, but if we wanted to create, say, 10 assassins, up here we would have to explicitly write out 7 more. That's going to take a ton of code. Whereas down here, if we wanted to create 7 more, it would just take 7 more lines of code. So every single new assassin we want to make now it just uses 1 line of code because we've done all the heavy lifting by creating this template, this class for assassin. So if we are a totally bomb crime boss and we have like thousands of assassins at our disposal, we now have a really sleek way of creating an object for each one so that we can keep track of them. So this is definitely how you want to approach creating classes. This is the right way to do it. Up here, this is the wrong way. So let's talk a little bit more about, what this is on a high level and how this relates to object-oriented programming. So you guys might have heard the phrase object-oriented programming thrown around. Some languages are object-oriented, some aren't. So for example, Java or C, C++, those are all object-oriented programming or programming languages. And that means that this type of class instantiation is everything. So if any of you guys are coming from those languages, this is going to look extremely familiar because this is how everything is done in those languages. As it were, JavaScript is not object-oriented. It's a very flexible language, so you can treat it like a functional language, you can treat it like an object-oriented language, but you don't really need to do either. So you could write an entirely valid JavaScript code base without ever using classes, but it's available to you, and in a lot of cases, it really is a useful tool to have under your belt. So this is a little bit of an insight into what object-oriented programming is. And as I talked about last night, their objects are really critical in JavaScript, in that behind the scenes, everything is an object. So this is a little bit of an insight into that as well, in that when something like the array class was created by the JavaScript developers, they were doing something very similar behind the scenes. And we're going to see a bit more of that at the end of the lesson tonight. And it relates a lot to what you guys were asking about last night with adding customized methods and kind of tinkering under the hood with what already exists in JavaScript. Okay, so let's, actually, before we move on, I want to mention one more thing, which is that this is not the only way to create a new class in JavaScript. So there are a handful of different ways to create classes in JavaScript. Admittedly, this also isn't the most common way to do it. So within ES6, which was a few years ago, they released a new version of JavaScript called ES6, in which there was a lot of updated functionality built in, like the const keyword, for example, didn't exist until a few years ago. So within ES6, there is a really sleek, useful way to create classes that you guys will learn about in the main curriculum. This is not it. And the reason that we decided to show you this instead of the ES6 approach is that the ES6 approach is so slick that it actually kind of hides what's going on behind the scenes. So it's something that's maybe easier to use, but it doesn't lend itself to comprehension of what's really going on here. So what we've done is called pseudo-classical instantiation. And I really like pseudo-classical instantiation because it lets you guys see what actually is going on. So we taught you this method because it's a good learning tool, but admittedly in the real world, this probably isn't how you would approach classes. But don't let that discourage you, because I promise you learning how to do this will make you a better programmer in general, and it'll make you better when you're writing ES6 classes. So if you are interested in learning more about those, I recommend you Googling them. But otherwise, don't worry about them. You'll learn them in the main curriculum in due time. Okay, so now we are ready to talk about the this keyword in a little bit more detail. So we saw this last night, and let me actually scroll up to some of our what not to do code to talk about how we saw this used last night. So I'm going to comment everything out down here for a minute, and we'll just take a look at this Ninja Assassin object that we have hard-coded in. So as we saw last night, we don't actually need the keyword this when we're hard-coding in methods in this way. So instead of saying this, I could have just explicitly said, hey, take Ninja Assassin's head count property and increment it. So now if I called ninjaassassin.kill, and then I'll go ahead and console log our ninja friend, we can see that the head count has been incremented successfully. So we didn't need the keyword this. We were able to hard code in the name of our object. But if we use the keyword this, it still works. This refers to the object that we're working inside of. So in that example, the keyword this doesn't really help us that much. It's one of the options, but we were able to hard code in. But let me go ahead and get rid of this, and I'll show you why it becomes really important when we're working with classes. So down here, we use the keyword this, and we have to, because this is going to refer to a specific assassin. So if we went ahead and changed this to assassin, it would no longer work. And this is a really subtle but important point, which is that assassin does not have a property called head count. Assassin is a template that contains some logic about the property head count, including other things, but the assassin object does not have a head count property. In fact, let's go ahead and console log the assassin object to see what it looks like. And let me get rid of these other console logs for just a second. So if we console log it, we see that this thing is only a function. It doesn't have any properties or methods on it. So this would be incorrect. And in fact, let me go ahead and do ninja_assassin.kill. And then I will go ahead and log our ninja assassin. We can see pretty clearly now that this kill function is broken because I've run the kill function, which is supposed to increment the head count. But then when I log the ninja assassin, we see it's still set to the default of 0. So this is not the correct syntax. We have to use the keyword this. Because what happens is when I call .kill on ninja assassin, this will refer to the ninja assassin specifically. If instead I called it on ghost assassin, then this would change. It would now refer to the ghost assassin specifically. So this always refers to whatever item is on the left side of the dot. So when you call kill, whatever is on the left side of the dot will be this in that case. So in that way, we can write this method, this general method, and have this dynamically refer to whichever object we're calling it on. So that is maybe a little bit more of an insight into what this is and how this works. And I do want to say that I think that the keyword this is extremely complex. And for me personally, it is honestly, I think, the most confusing part of JavaScript. What we've seen right now is kind of a basic example, and admittedly, it can get a lot more confusing. But even this basic example can be kind of mind-numbing, especially when you're seeing it for the first time. So I want you guys to be really patient with yourself as you're using the keyword this, because it really is one of those things that takes practice. So don't be afraid of it, and especially if you're creating classes, you're going to need it. But have some patience with yourself. Feel free to rewatch this section or, find other resources on this, because I can tell you it is one of the most mind-boggling pieces of JavaScript, but it's also really cool, and it allows us to do dynamic things like create these general methods that work for tons of different objects. All right, so that is a little intro to the keyword this. Now I want to talk about the prototype. So we got a little sneak preview into the prototype last night because we had some really great questions. But I kept saying, hold tight, you'll learn more about it tomorrow, and now it is the time for that. So we have done a lot of cool stuff here with creating our new class of assassin, actually creating 3 different instances of assassins. And then over here, we were able to actually use them, do some killing, see that the functionality works out. But I will admit to you guys that there is one thing that I've done so far that is not best practice. And that is the way that I wrote this kill method. And let me explain to you why. So what happens when I create the ninja assassin is I create a new copy of this kill function. So there is a brand new copy of this kill function that lives on the ninja assassin. And in fact, when we log our different assassins, we see that there is a copy right there. We see that there's Another copy on the character assassin. Oops. So we have 3 copies of this, technically 4 copies of this function existing in memory right now. We have the original, and then we have 3 different copies that we have, distinct copies that we have created. So as I mentioned earlier, we might be this crime boss that has thousands of assassins in our employ, in which case we would want to create thousands of these assassin instances, which means thousands of copies of this kill function. And that is a total waste of space. Admittedly, functions are not that memory intensive, but what if instead of thousands, we had hundreds of thousands of assassins? Now we're creating the exact same thing in memory 1,000 different times. And that's not good. It's a waste. We're literally wasting resources on paying for memory that we're not using. And if we're a crime boss, we probably need our resources to hire assassins and, like buy solid gold toilet seats or things like that. So we can't be doing that. We need a better way. And that's where the prototype comes into play. So another thing that happens behind the scenes here is that the assassin has an object put on it called prototype. So it starts as just an empty object. And we can think of this as like the community pool. So anything that's going to be communal amongst all of our different assassins should go in the prototype. And methods tend to be the most glaring example of this, because methods are usually, you want the method logic to be exactly the same for every instance. So it should go on the prototype. So I'm going to actually delete this thing and put it on the prototype where it goes. So below here, I will go ahead and put this thing directly onto the prototype. I can go this dot head count plus. So now we have, instead of putting it on each individual, we've put it on the prototype. So one thing that means, and actually let me leave that in. So first, let's confirm that our kill function is still working. It looks like it is, because we are able to increment the head count on the ghost assassin. But notice that something has changed. Whereas before, we had that method actually on the object. We could see it when we logged the object. Now it's out of sight. Instead, it's on the prototype. So let me go ahead and instead log assassin.prototype. You can see instead it exists on the prototype. But we're still allowed to use it. Well, why? Here's what happens when you call a method on an object. So the first place that we're going to look for this method is inside of Ghost Assassin himself. So when we call this, we will initially look for, or the computer will initially look inside of Ghost Assassin to see if there's a kill method. And as we saw, let me log our Ghost Assassin friend again. As we saw, there is no kill method inside of here. So if it doesn't find the method, then the second place it looks is inside of the prototype. So then it will look inside of assassin.prototype, and that function does exist there, so it executes that instead. And because of this, it doesn't matter, because of the keyword this, it doesn't matter where we put this function. This will always refer to whichever object is on the left side of this function call. So we're able to use the method without ever having to put it directly on the object. So let me go ahead and explain one more time why this is the preferred method, why we want to do it that way. And that's because initially we were creating a new copy of the kill function every time we created a new instance of assassin. And that means that if we have 100,000 assassins, we have 100,000 copies of this exact same kill function, just wasting our memory. So instead, now we just have one copy of it. There's literally one copy that lives in memory, and everybody communally uses that same copy of the function. So this, the keyword this, it will that will change what that's referencing, but the place that the function actually lives is going to be communal. So that's really good, especially with big production level code bases. So for example, if you're working for Facebook and you were creating a class for users, you would absolutely want to use the prototype to create your methods, because there are millions, maybe billions of people on Facebook, and you wouldn't want to create a new copy of method for every single Facebook user. That would be a massive waste of resources. So that is the preferred way of writing methods. You want to write methods using the prototype. Now let me go ahead and tie this into some of the things that we were talking about last night in our Q&A session, because what's really cool about understanding the prototype and how the prototype works is that this gives us an extra tool to kind of get under the hood of JavaScript and really not only really understand what's going on, but really use everything that's at our disposal. So I am actually going to go ahead and get rid of all of this assassin logic so that we can work with some familiar objects. So the first thing I want to do is actually explore some prototypes that exist for pre-existing JavaScript objects or JavaScript types. So I'm going to go ahead and open the console over here. So the only reason I'm doing this is because CodePen kind of hides some of the internal logic, so you can't really see what's going on in CodePen. So instead, I opened the console. And as a reminder, that's Option Command J if you're on a Mac. All right, so if I want to look at, for example, array.prototype, all I would have to do is type array, which array capitalized refers to the class of array. And then I can see a list of all the different methods on the array. And we can see that they all live on the prototype. So we see some of the methods that we've already explored this week, like pop and push. We can also see a bunch of other methods that we haven't seen yet. We'll, in fact, learn some of these in next week in our callback lesson. So we can see that array.prototype has all these communal methods. So what we just learned how to do with the assassin class is something that the JavaScript developers were doing when they actually created the class of objects called array. Let's look at string.prototype. So this thing also has a boatload of methods, all living on the prototype. How about Boolean.prototype? So notice that there isn't much here. So we don't really use a whole lot of methods on Booleans, so we don't see much going on here. And finally, if we look at object.prototype, we can see all the communal methods. So for example, I mentioned toString last night, which is a method that every single type of object has, and that's because it exists on the object prototype. So this is kind of the most core prototype. Whereas up here, these are only specific to arrays, and the methods here are only specific to strings. So inside the console, we can actually get a little glimpse into what's going on behind the scenes. So last night, I used the word costume to refer to, for example, an array is an object wearing an array costume. Now we can get a little more specific and technical and say, okay, an array is a class of object. When we create an array, we're actually creating a new instance of the array class, which is a type of object. So that's a really great look behind the scenes at the prototype. Another thing I want to go over again, which we talked a little bit about in the Q&A, is adding new methods onto existing prototypes. So we saw this last night, but I think it'll make even more sense tonight now that we've gotten a glimpse at what's actually happening. So as we know, there's, or maybe you don't know, but just so you know, arrays do not have a method for getting the last item in the array. So if we had, let's just create a new array. If we wanted to get the last item in this array, we would have to do array@array.length -1. because of zero indexing, the last item will always be at the length minus 1. So in that way, we could get the last item, even if I added more things on here. But what if we wanted to create a method to do this for us? Well, we could just go ahead and put that on the array prototype. So if we do array.prototype. I'll call it getLast. And then we'll return this at, wait, I'll do length equals this.length. And then we will do return this at length minus 1. Okay, so what I've done is I've used the keyword this to get the length of the array. And then I went ahead and used bracket notation to grab the item at index length minus 1. So now that I've put this on the prototype, I can do array.getLast. And the same thing happens. And if I created a second array, then array 2 would also have the getLast method. So because it's on the prototype, every single array has access to it. So this is actually a really useful technique. Sometimes we find ourselves doing the exact same things over and over again with an array, and it turns out that our code would really benefit from writing a new method onto the array prototype. Another crazy thing that we can do is overwrite array methods. So this one, I'll admit, isn't necessarily something you want to be doing. I personally have never had a case in the real world where I've done this, but it's something kind of cool that we can do. And I think it's a kind of fun little example of a way that we can use this type of logic. So we know that array.push will push a new item onto our object. So if I push on 8, do the number 8, and then I look at my array, I can see that I've pushed an A onto the end. But if we wanted to go ahead and troll our fellow developers, we could actually change what push does. So we could overwrite array.push on the prototype. So it's in an item. And let's say instead of pushing it on the end, we wanted to just put it in the first slot. So instead of sticking it on the back, we're just going to overwrite whatever is in the first spot with this. So now if I do array.push, instead of pushing it on the end like it's supposed to, it sticks it on the front. So I think the built-in version of push is a bit more useful than my strange convoluted version of push, but we can if we want to. So that's kind of cool. Okay, well, that is everything I wanted to show you guys tonight. But before we go into questions, I want to do a quick review of everything we learned tonight because it was a lot. So what we saw is that when we have a case in JavaScript where we're creating the same type of objects, so if we have user1 name, and then we have user2, who of course also has a name. I guess we'll make these like actual usernames. So whenever we're creating these objects that have the same format as each other, instead of just hard coding in a new object every time, we want to create a class, which is a template for them. So instead, we would create our user class, which is going to take in a name and a password. And then we can just go ahead and assign these on here. So we can say this.name equals name, this.password equals password. And then if instead of doing this happy business up here, we could create new users really easily. So we would do user1 equals new user. And remember, we always use the keyword new when we're declaring our new classes or a new instance of a class. So if we're just declaring, or if we're just calling a function, no keyword new. If it's a class, keyword new. So then I could do Deandra and my password. And then I have user1 available to me. And in this way, I can create hundreds of thousands of new users really quickly. And if I wanted a method on this user, I could always do user.prototype. We'll do say name. And we can have this method console log. So now if we do user1.sayName, it works. So all these properties will go in inside of the actual class function, and then any methods we want, we put directly on the prototype. And the reason for that, again, is so that we're not creating thousands of copies of the sayName function. Instead, we only have one copy in memory that all users can use. So that is the gist of classes. So once again, a behind the scenes look at what is really going on in JavaScript. We now know that these different data types that I've been teaching you since last Thursday of string, Boolean, array, are actually all just classes behind the scenes. They have these properties that are assigned in the constructor. They have methods that are put on the prototype. But everything happens behind the scenes in this nice way so that we can use them really easily without having to, for example, use the keyword new every time we want to create a new string, which would be a big hassle. So there's these nice shortcuts that JavaScript has taken for us so that we don't have to. Let me just show you this actually. So if we wanted to create a string, we could do new string and put in the value of the string. And that's, if we do it this way, it's very clear that we're using a class called string. But how big of a hassle would it be if we had to type this every single time we created a string? So instead, there's a shortcut in JavaScript, which is we can just create the string and it knows what we're talking about. So, but always keep in mind that behind the scenes, we're creating a new instance of the class string when we do this. Okay, that is all I have for you guys for tonight. Let's go ahead and open up to questions. And yes, if there are any good questions in the YouTube chat, I unfortunately can't keep track of too many questions or chat threads all at once. So yeah, anything from the YouTube channel that's a good question, feel free to copy and paste into Slack and I will answer that. I do see a question that's up already, which is that Kenneth asked, how do you determine what methods/functions to use for a prototype instead of normally typing it into the class? So I would say every single method is going to be on the prototype. So there's probably some exceptions to this where, for example, honestly, I can't think of a good example that you would ever want a method actually inside. So methods should always go onto the prototype, whereas properties go inside of the class function. So, and as a reminder, the difference between a method and a property is that a method is a function. All right, I see we have some typing going on. We'll sit tight and wait for that. Yep, so to follow up with Kenneth, you always want methods to be on the prototype. So every time you're writing, if you're creating a new class and your class has a method, always put it on the prototype. Okay, so someone whose name I will butcher if I attempt to pronounce it asked in the YouTube chat, where is the prototype stored? So the prototype itself is actually a property. So this is where things get really, really meta. So let me pull up this class of user once again. So it has a username and a password. Okay. And then we do site username. So when I just run this line of code, I have not created any instance of users. No users actually exist, but this object called user exists. And as I said before, this thing isn't a specific user, but it's a rule book. It tells us how to create users. So there is an object called user that we've created. Now, user is a function, but as I said, everything is secretly an object behind the scenes. So even though when we log this, it says, oh, user is a function, it actually is an object as well. And so because objects can have properties, one of the properties that user has is something called prototype. And this user.prototype object is automatically created. So behind the scenes, this is happening. We're putting an empty object as a property on prototype. And every single class variable has a prototype, as I was showing you in the console. So if I just log user.prototype right now, it's an empty object. But then I can start to add methods like, which I'm not going to type out. So by default, every single class variable will have a method called prototype, or sorry, a property called prototype where you put the methods. So to directly answer that question of where is the prototype stored, every single class variable has an object called prototype that actually is a property that lives on it. Do we have any more questions out there? All right, it looks like we are done with questions for tonight, so I will let you guys go a little bit early. All right, thanks for sticking with me tonight and learning a little bit about classes. I hope that you guys are understanding this and starting to get excited about JavaScript and starting to feel like you're getting a glimpse at what's really going on behind the scenes. And I do want to say that the more, with any deep topic, JavaScript being no exception, the more you learn, the more you start to feel like, oh geez, I really don't understand what's going on here. And that's okay. To me, that a little bit of disorientation is a sign that you're actually starting to get a grasp at how complex this thing truly is. So as usual, you have some homework tonight that will be up on GitHub. Same process, you'll be able to run tests using your terminal and then submit it to GitHub with a pull request when you're finished. So good luck with the homework. Feel free to ask any questions in the Slack questions channel. Feel free to Google. Always recommend developing that skill. And I will see you guys next week. So I'll see you guys next Monday for our last week of the mini bootcamp. I hope you guys have a great weekend and go ahead and build some cool classes while we're away for the break. So I'll see you next week. All right, have a good night.